Section 1.5 is infinite limits. And to start with, we're going to look at a definition that sounds really wordy. That's what it sounds like. It sounds really wordy. Let f be a function defined at every real number on some open interval containing c, except possibly at c itself. So there might be a hole or an asymptote or a jump at c, but everywhere else we're good. The statement that the limit as x approaches c of f of x is equal to infinity means that for every m greater than 0, there exists a delta greater than 0, such that f of x greater than m whenever 0 is less than x minus c is less than delta. And a similar statement can be made for negative values. So fill those details in on your notes, and then I'm going to draw you a picture of what it's describing. I'm going to draw my picture like there's an asymptote. We know there's some kind of a problem. I'm going to draw it as an asymptote problem. So I've got some kind of a curve like this. We're assuming there's some kind of an asymptote here through here. Oh, it's terrible. Okay? And that's at C. What all this is saying is that if you pick a height greater than 0, called m, or if I pick a big number, a bigger than 0 number, m, and I sort of go on over here, right, that there are values that are above the value m, right? You see them right here. These are all the values we're talking about. There are values that happen. And in particular, no matter how high m is, it narrows how close I need to be to the asymptote to make that work. That's all it's saying. And this distance away that it's talking about from the asymptote, this distance is delta. So if you say, okay, well, yay, that's great, but what if the m were bigger? Instead of 100, it's 1,000. Okay, let's make it 1,000, and it just narrows how close I need to be to the x value of c to make that work. So that's all this theorem is saying, or definition is saying, is that I will be able to get close enough to c to still find a bigger value than m to make that work. And if I flipped this whole image upside down, we could do the same thing and talk about the values that are negative. So if I have the ability to continue choosing bigger and bigger values of m, the closer and closer I get to that asymptote, what we say is that the limit, when we have this happening, is in fact infinity. There's a note here that I want to make sure that you're very clear on. Be sure you see that the equal sign in this statement, the limit as x approaches c of f of x equals infinity, does not mean that the limit exists. The limit still does not exist. On the contrary, it tells you how the limit fails to exist by denoting the unbounded behavior of f of x as x approaches c. It still does not exist, but telling me it does not exist could mean I have an asymptote, a hole, I could have a jump in the graph, I could have any of those potential things. By saying it equals infinity, I know it doesn't exist and I know how. It doesn't exist because there's an asymptote. That's how it fails to exist. So let me do one quick example and then we'll stop for today. I'll post a video for the remaining pieces of the problems. This one says to determine whether f of x approaches infinity or negative infinity as x approaches 4 from the left and as x approaches 4 from the right. So here's the deal. You have two options when you're trying to decide what happens from two sides of something that has an asymptote. If you attempt to simply plug in 4 here, what are you going to get? 0. In particular, only in the denominator. So there's no factoring, there's no canceling out, right? This is definitely an asymptote. So you need to either look at a graph or a table. Kind of like graphs. I feel like they work pretty cleanly on this problem. So let me show you what a graph roughly of this one would look like. It looks roughly like this. So the directions say find the limit as x approaches 4 from the left of negative, well, actually it calls it f of x, so I'll just put f of x in here. And the limit as x approaches 4 from the right of f of x. So on my graph, from the left, I'm over here. What is the limit as we approach x from the left-hand side or the negative side? It's negative infinity, right? I'm tanking fast. And then if I approach x equals 4 from the right-hand side, what is it? Positive infinity. It's the blue parts. Oh, I'm sorry though, I drew my graph upside down because I didn't have the negative on it. Change everything. Let me flip my graph. I'm so sorry. When I sketch, that's what happens when you don't sketch the graph from your calculator. All right, let me fix the graph real quick and then we'll be done. The graph is supposed to look like this. There we go. So from the right, it's negative infinity. And from the left, it was positive infinity. Okay, everybody good with that? All right, so I'll be posting the rest of 1.5 when I have a chance to later today. Homework on WebAssign will be due for 1.4 and 1.5 on Tuesday. It's 5 days from now, still a good chunk of time. And we will have a quiz on Tuesday as well. Tuesday, we will also be reviewing for our first test, which is next Thursday. Coming so fast with all the crazy stuff going on, right? All right, I'll see you guys on Tuesday.